All right, good morning, good afternoon, whenever you are. Hope you're doing well. Hey, we're going to get into section 4.2 here in a moment. You can see at the top here what we're actually going to be looking at, or what the focus of actually the entire chapter is really going to be over, which is knowing how to understand how to prove triangles are congruent. Because let's be honest, folks, when you have more complex figures, multiple sided polygons, and you want to look deeply into what the characteristics are of these polygons, really everything comes back to the most basic polygon. That's a triangle. So as we take a look at this, just keep that in mind. The focus is to know and understand how to prove triangles are congruent. Now, what I will also tell you is this. There are shortcut methods. I'm going to walk you through kind of the longer, drawn out, hey, this all is true if we have congruent triangles. But there are shortcut methods to prove triangles congruent. So if you think to yourself as we get going with this lesson, hey, this is a lot, Mr. Couples. Do I really need to do all of this? The answer is no. We're going to talk about shortcuts here, so just keep that in mind. All right, let's kind of get into it and start looking at what we have here. Starting with congruence and corresponding parts. It says polygons that can be mapped exactly onto one another, geometric figure, are congruent. So that kind of makes sense here, is if I was to cut this triangle out and rotate it over, you'd have the exact same triangle mapped onto itself. These corresponding parts would all match together. Polygons are congruent polygons if and only if, okay, all pairs of corresponding angles and are congruent, and all pairs of corresponding sides are congruent, okay? Now, another way to say this, and we'll talk about this more later on in this chapter, is by CPCTC, okay? And you will want to memorize this acronym here. Here's what it stands for: corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent. So as I kind of underline those first letters that make up CPCTC, that's what I really need you to make sure you understand. If these triangles are congruent, the side that corresponds with this one has to be congruent to that same side on the other triangle. Okay? This angle, that corresponding angle, has to be congruent. This side that corresponds to it on the other triangle has to be congruent. These two angles, which correspond, have to be congruent, and these two sides, and then these two angles. Okay? So all the parts, all those corresponding parts of congruent triangles have to be congruent. Okay? That's what I really need to make sure you understand from all this. As you take a look at the next part, the quick example, if these triangles are congruent, name the pairs of congruent angles and sides. Here's what I want you to know. As I look up here at this congruency statement, this is called a congruency statement. So maybe you want to go ahead and jot that off to the side. Congruency statement. Okay? For example, I can write a congruency statement with this up here. If you notice, angle A and angle R are the first letters because they correspond. Angle B and angle S, they correspond, so they would have to be the congruent ones. And then C and T would have to be congruent, okay? So again, you write your congruency statement based on how those angles correspond to each other, okay? So as I look at this, without even looking over here, I know that I'll start with ZY. I know that ZY right here, that segment, is congruent to ST. So if I look over here, ZY, ST, the exact same segment measurements, okay? I also know that XZ, the first and third letters, that segment has to be congruent to RT. So XZ and RT, and you can see that by the congruency markings there, okay? So if I go through the angles, angle X and angle R, that makes sense to the first letters, Y and S, would have to be the same measures, and Z and T would have to be the same measures, okay? As far as the segments, XY and RS, if I look here, XY, RS, XY, RS, okay, I think you have it down there. We'll talk more about congruency statements here in a second. So, as we move down to the next section, it says here, show that the polygons are congruent by using rigid motions. Now remember, the rigid motions that we've talked about so far are going to be rotations, reflections, or translations. Okay, it can be any of those right there, rotation, reflection, or translation. And by identifying all congruent corresponding parts, then write the congruent statement, okay? So if I look at this, as I look at this one, number one, I'm going to say that this is just going to be a translation, okay? I can take this and slide it over and up, and I'll have the exact same figure. Now from there, if I was to mark out the corresponding parts, angle A is congruent to angle J. Again, I can see that by the congruency markings. Angle B is congruent to angle K. And angle C is congruent to angle L. Okay. As far as segments, again, looking at the congruency markings, AB is congruent to JK. And I know that BC is congruent to KL. Oh, I'm getting a little below here. I'm sorry. Okay. And then the last one, just congruency markings, AC is congruent to JL. Okay, just matching up all those corresponding markings there. Now, I can also write the congruent statement, or the congruency statement, and I'll go ahead and do something like this. If I say triangle BAC, okay, it doesn't matter what order you start with, you just have to match up those corresponding parts from the other triangles. So if I do BAC, it would have to be KJL, okay? Those angles have to be written in the same order, okay? If I was to do CAB, triangle CAB, CAB, this would be triangle LJK, okay? So again, it's very, very important to know how to write your congruency statement. I hope that made sense to you, okay? Okay, now, if I move over to number 3, here it says this, it gives me this information. As I look here, I think I could go ahead and map this one onto this one by using a line of reflection right here. So if I was to do something like this, the only problem is, do I know that this angle and this angle are congruent? Or that this angle and this angle are congruent? The answer is no, not right now. Now, I will tell you this, later on in this chapter, we can easily prove these triangles congruent using several different methods. But for right now, I'm going to put down that this is a no conclusion. Okay? Because remember, all of those corresponding parts have to be congruent to each other. Okay? Let's look at number 4 here real quick. As I look at number 4, I don't have everything marked congruent. So I don't know if they are all congruent to each other. However, I do know, and this will be important moving forward, that this angle and this angle are congruent to each other. Okay? And what that is called, the reason why those are congruent is because these are alternate interior angles. And when lines are parallel, I know that alternate interior angles have to be congruent. Likewise, these two angles are congruent because, again, if lines are parallel, the alternate interior angles have to be congruent. So I'm going to write this down. Now remember, there's multiple angles here at the vertex of K. So I'm actually going to write down angle LKM is congruent to angle JMK. And I'm going to go ahead and say that angle LMK is congruent to angle JKM. And I'll just make a little note to myself. This was by the alternate interior angles theorem. Okay, that's how I know that those are congruent to each other. Now, something we haven't learned quite yet, but we will learn down the road is this. If you have two angles congruent to two angles of another triangle, so these two are congruent to these two have to be congruent as well because their sum is 180 in both triangles. So I'm going to go ahead and put down this, that angle J is congruent to angle L, and this is by the third angles theorem. The third angles theorem, which basically says if you have two angles from two different triangles congruent, the third angles have to be congruent as well. Okay. Now from here, let's talk about the side lengths. Well, I know that JK, two congruency marks there, are congruent to LM. So JK is congruent to LM. Okay. I also know that KL is congruent to JM. Okay, and then this segment right here, which really seems inconspicuous, it really doesn't look like it has much to do with the problem, but it is the same side length in both triangles. And so I'm going to write down that KM is congruent to KM by the reflexive property. If you remember the reflexive property, I told you when we went over it in chapter 2, A equals A is the reflexive property, okay? That we wouldn't use it a whole lot until we got to the proof chapter, and that's this chapter. So you'll use this reflexive property. It's shared by both triangles, okay? So from here, my congruency statement would be something like this. I'll start with L. LMK. Okay, again, it doesn't matter which angle you start with, but if I go in the order of LMK, the corresponding angle to L would be J, M would be K, and then L would be M, okay? So again, write that in the corresponding order, LMK, LMK. So it's the same angles. Now how did I get that? If I were to rotate this triangle here 180 degrees around that point right there, I am going to get the new triangle. Okay, so I have a rotation there. All right. All right, let's go ahead and turn to the next page now. I'm actually going to have you finish up the rest of the problems on that page, which I don't think should be too super hard. I'm actually going to have you guys go ahead and do the next section. Here's what I'm going to tell you. Hint, hint, if the triangles are congruent, we know that all of the corresponding parts of the congruent triangles are congruent, okay? So we know that every single part is congruent. So if I look here, AB, that segment there is congruent to DE, okay? I know that BC is congruent to EF. And I know that AC, notice I did that, AC is congruent to DF. I also know that angle A is congruent to angle D. So if I mark angle A and angle D congruent, interesting. Angle B is congruent to angle E. And then angle C is congruent to angle F. Okay? I'm going to give you a moment to go ahead and try to figure out what both X and Y are. In the meantime, actually I'm going to give you one moment. I am going to go ahead and... All right, so moving on to the second section of 4, it talks about how to prove triangles congruent. Two triangles are congruent if and only if their corresponding parts are congruent, which we already knew that. Corresponding parts include corresponding angles and corresponding sides. The phrase if and only if means that both the conditional and its converse are true. So if two polygons are congruent, then their corresponding parts are congruent. I hope that you caught on to that. That's a good point right there. For triangles, we say corresponding parts are congruent, of congruent triangles are congruent, the CP, CTC. So I just talked about that. This part down here, with the third angles theorem, we also just talked about if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. If you're a visual person, maybe you draw something like this out and say something like this. if this is true here, guys, if this is true, A, B, C, D, E, F, then angle C has to be congruent to angle F because their sum is 180. So if this is 100 and this is 50, and this is 100 and this is 50, then this is 30, but so is this. This is 30 as well, okay? So, yeah, hopefully you've got that down. All right, now, moving on to, I'm going to do number 1 down here. You're going to do the example up here. You're going to try to fill in what's missing up there. Just fill in those missing parts. You're going to do the same thing on number 2 on the backside, okay? You're going to try to fill in those missing parts, and then we'll come back and we'll talk about those. But as I look at this, here's what we have. Okay, we're going to write a 2-column proof. Holy shnikes, they're giving us a lot of stuff. That's a good thing because that means less work for us to figure out in the long run. So I'm going to write this down. Angle A is congruent to angle C. As I do that, I'm going to mark out that in my picture. Angle D is congruent to angle B. D is congruent to angle B. I know that AD is, let's actually stop right there. Maybe I'll just pause for a moment and ask you, just looking at the picture, what else do you think is going to be true? Okay. Well, I'm hoping that you're thinking, well, if these 2 angles are congruent to these 2 angles, I know that this angle and this angle have to be congruent. Okay. So for step number 2, I'm going to write something like this down. Angle AED is congruent to angle CEB. So number 1 obviously was the given again. Don't forget that. We covered that earlier. And I can write this in one of 2 ways. Probably a lot of you are thinking the third angles theorem. Third angles theorem. And I'm fine with that. Or, does anybody know how else we could have proven those 2 angles to be congruent? What do we call these 2 angles? They're called vertical angles, right? So I'm going to put down vertical angles theorem. I'm okay with either one of those, whichever one you want to go ahead and put down, okay? Now, I could have put the entire given in the first step, but I'm going to hold off and use the segments for the third step here. So I'm going to say AD is congruent to CB. I'm going to say that AE is congruent to CE. And then they're not as specific on this next part. They say that AC bisects, I should have marked these. AD is congruent to BC. AE is congruent to EC. And then we know that AC bisects BD. Okay? So that this third step, again, is the given. Okay? Still a given. Now from here, if I go to the 4th step, we don't know that this segment is congruent to this one. But if I clearly define what this means, that's going to help me tell that there's something else that's true. So if AC, remember, what does bisects mean? It means to cut in half. So if AC is cutting in half BD, well, then what do we know? Well, if this segment cuts this one in half, these 2 segments have to be equal. So I'm going to say that BE is congruent to ED by the definition of bisects. Okay? Now, if that's true, what do we then know? Well, are all my corresponding sides and angles congruent? The answer is yes. And so what I'm going to say is this. I'm going to say that the triangle AED is congruent to triangle CEB by the definition of congruent triangles. Okay, so again, what is the definition of congruent triangles? It's that all the corresponding parts have to be congruent, sides and angles. Okay. Now, as I look at this, how can I map one of these triangles onto the other one? If I was to turn it, if I was to rotate it. So I'm going to say rotation. And if you want to be real specific, it looks like it's probably going to be 180 degrees. Okay, 180 degree rotation there for that rigid motion. All right, folks, you have a couple of problems to finish up for me from the packet here. I'd like you to go ahead and do that. If you have any questions, let me know. Otherwise, thank you for listening. I know that was a little bit longer video, but hopefully it all made sense to you. Have a great day. We'll talk to you later.